So a common problem you'll see is a question like this. The following polygons are similar. Find the missing side lengths. So they're going to give you two polygons. Let's do a quick example starting off with just two triangles. Okay, and let's give this a side length of let's say 3, 20, actually no, not 20, let me try that again. Let's do 3 and 6. And over here we've got 15 and x. So that means x, that's the side length that we're trying to find. Now, there are two steps to solving a question like this. Step 1 is to find the scale factor. So let's go back to the question. Let's find our scale factor here. So we do know that we have this side length here is 15, and I know it used to be 3. So just based on that alone, we can find the scale factor by doing the new distance, so 15 divided by what it used to be, 3, and that gets me a scale factor of 5. Now, once you have that scale factor, you're ready for the second step. You're going to use that to find the missing side. Sorry. Now, when I say use that, you're going to either multiply or divide. It kind of depends on which direction you're going if you're trying to find the side length of a bigger object or the smaller object. So we know that scale factor is the number that we use to multiply to go from the first object to the next one. So here we did 3 times 5 to get 15. So that means I'm going to do 6 times 5 to get our x value. So 6 times 5 is 30, and that would be our solution. Let's try another one. So these two triangles are similar. So we know that they use the same scale factor to get from 2 to 0.5 and then 20 to the x. So step 1, we're going to find our scale factor. I'm going to do the new length that we know, 0.5, divided by what it used to be, which is 2. And 0.5 divided by 2 is 0.25. So that's my scale factor. So that's what I'm going to multiply 20 by to get our value of x. 20 times 0.25, and that would get me an x value of 5. So that would be the side length of x there. Now, sometimes the missing side length, the x value, is on the original polygon, and so your strategy changes a little bit in that case. So let's take a look at a question like that now. Okay, so here you can see that our missing side length is actually in the original drawing. So the problem is that if we were to find the scale factor, well, x times that scale factor would get me 6. Let me show you what would happen if we did it that way. So I'm going to take one of the new distances, let's say this distance here, 10, and we're going to divide it by what it used to be. It used to be 90. And 10 divided by 90 is actually 1 out of 9, and if you're going to write that as a fraction, it's actually 0.1 repeating. So this means our unknown value, or x, times that becomes 6. So I can write it down like this. X times 0.1 repeating equals 6. So to figure out our x value, that's just like algebra, I'm going to divide both sides by 0.1 repeating. And then those would cancel out. And if we calculate that, you would get x equals, well, 54.000 blah, 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 but it should be exactly 54. Now let me quickly show you another method of solving this that might be a little bit easier. since our unknown value is on this side, you could also just reverse the direction and pretend that we're actually doing an enlargement. We're going from this side to this side. So to find our scale factor in that case, if this is the new distance, it would be 90 divided by 10. So our scale factor would be a much simpler number. It's just 9. So I would do 6 times 9 to get our value of x, which is 54. So that method might be a little bit easier because you're not dealing with decimals and fractions. But either way, you get the same answer.